Hey everyone, I'm Tobi at Humanitec, and I'm going to walk you through the Quickstart guide today. The Quickstart is sort of a guided tour through all of the Humanitec product fundamentals. At the end, you will have connected your own Kubernetes cluster to the Platform Orchestrator, deployed a workload with associated resources, and you'll have a hands-on knowledge on all the fundamental concepts that we're using. This will take no more than 60 minutes. If that sounds good, stay tuned and let's dive right in. You will find the Quickstart as part of our developer documentation. So if you go to developer.humanitec.com and you move over to the right, you'll find the training section right here. And in the training section, you will find the Quickstart right here. There are a few prerequisites I'd like to point out. So you obviously need a Humanitec account to get started. You also need a Kubernetes cluster, and it has to have a publicly accessible API server endpoint. That is quite important for this Quickstart, so that the Platform Orchestrator can access your cluster to deploy workloads and other stuff. Now, there is a way to work with private clusters as well. It's called the Humanitec agent. It's linked further down on the page, but it's out of scope for this Quickstart. To keep things simple, we're going to work with a publicly accessible cluster. It can be any sort of cluster. It can be hosted in one of the three major cloud providers, Azure, AWS, or Google Cloud, or it can be any generic cluster. If you have one of the major cloud providers, check out the specific requirements that are laid out right here and make sure your cluster fulfills those. You also need a couple of CLI tools ready. So there's Git, Terraform, kubectl with a context connected to your cluster, and our very own Humanitec CLI, which is called humctl. Depending on the cloud you're using, your CLI needs to be authenticated to the cloud. And this is it. So let's start by configuring our environment. We are providing a backing repo, which is public on GitHub to work with. So the first thing I'm going to do, I'm going to clone this repo to my local machine by copying these instructions. So I'm going to clone the repo and cd it into it. Great. Next thing to do is to define the cloud I'm using so that the scripts that are part of the repo can do the proper job. So for this demo, I'm going to use Google Cloud. So I'm going to put in GCP. If you're using a different cloud, you put in AWS or Azure, or just generic if you're using a generic cluster. So it's GCP for me. And you also have to make sure you are authenticated to your CLI. I've already done that ahead of time. Now we do provide convenience scripts to create a cluster at this point if you do not have one ready. So if you don't have a cluster ready that fulfills the requirements, you can at this point execute this convenience script for any of the three major clouds to create an opinionated default cluster with all the requirements that we need. It will be public and we can tear it down again afterwards. So next is I'm going to edit this configuration file. I'm going to open VS Code to make it a little easier. I'm going to edit this NFRC file and provide a very small amount of information. So the first thing we need is our Humanitec organization. I'm going to put in my Humanitec organization ID. If you don't know it, you can find it in the portal right up here. If you've logged in, you'll find this part of the URL. This is your organization ID. So that's one piece. And the other thing is, well, we need access to your cluster. So we need the required information to locate it. So I'm going to go down to the appropriate section. In this case, it's Google Cloud for me. I'm going to put in the name and region of my demo cluster. So CGC-Docs Tutorials GKE. And the cluster region for this cluster is Europe West 3. If you're using AKS, it's going to be a different set of information. If you're using Azure, it's another different set. But for Google Cloud, it's those two pieces. Double check, they're correct. Looks good. Cool. So next thing to do is we're going to execute the script to apply these variables to our environment. So this is it. If you haven't already done so, you can go and log into your Platform Orchestrator by doing humctl login. I've already done that ahead of time. So we're now ready to go ahead and connect our cluster. So the first thing to connect our cluster is create what's called a cloud account. A cloud account is a piece of configuration in the Platform Orchestrator that stores credentials to one of the major clouds. So in my case, I'm going to create a cloud account that defines some sort of access into Google Cloud. This access will be backed by access management elements that I need to set up in Google Cloud. So I need some kind of principal with the proper permissions that is then mapped onto this cloud account. There's a lot more details on the specialized pages on cloud accounts. They are linked right here. If you want to take a closer look, for the sake of Quickstart, that's basically all you need to know. We have created convenience scripts to create this cloud account that reiterate the instructions from these pages to make it a little faster. So let's create a cloud account for Google Cloud, which means we're going to have to create a set of elements in Google Cloud to begin with, and then create the actual cloud account in the Platform Orchestrator. I can take a look at it by using the humctl CLI. If we do humctl get resource account, which is the cloud account in the API, I get the output defining this cloud account. There's not a lot we can see. It's a very simple thing, and it does not display any of the secret information that's in there. But you can also see it in the portal. If you go to cloud accounts, there's a newly created Quickstart GCP cloud account right here. Great. So that's step one. Next is to actually create access to your particular cluster. The cluster, in the terms of the Platform Orchestrator, is a resource. Pretty much anything is a resource that is not directly associated to a workload. So what we need to do is create what's called a resource definition. The resource definition defines the parameters, the configuration for a particular resource. And this time, and in this case, it's for the Kubernetes cluster we want to connect to. So to connect your cluster, again, there are detailed instructions in the developer docs that are linked right here. And to make it easy and quick, we can just execute our convenience script and connect to our cluster. So there's a number of things that are not happening. We're getting access permissions set for the principal that's used in the cloud account in Google Cloud, and we will be creating this resource definition in a minute. So that was the cluster access, and we will now create the actual resource definition. First, we're going to create the local YAML file that we can then going to deploy. We can have a look at it. So this is the YAML definition of that resource definition for the cluster, and you'll see a number of things. It has a type of Kubernetes cluster. It will have the name of GCP Quickstart, and it references the account that we created previously. So this line is actually a reference to the cloud account that will be used to then effectively access your Kubernetes cluster. So to reiterate, cloud account, credentials to your cloud, resource definition for your cluster, uses the cloud account to then actually connect to it. And there's some more information down here, which is basically, well, how do I find the cluster? And this was it. So we can now apply this resource definition and get started. Great, this was it. And if we now go back to the Platform Orchestrator and you go to Resource Management, let me filter by Quickstart, we should now see this new resource definition, GCP Quickstart, that we just prepared, ready to go. Is it really ready? Well, we're going to find out in a minute. Let's now start to actually deploy a workload and have a quick look at what we achieved so far. So we now created this cloud account. We created the resource definition for the cluster. Those two are linked to each other. So the resource definition references the cloud account, and that will then enable us to access the cloud infrastructure and our cluster in particular. So we're now good to go and deploy our first application. First, we're going to create an application in the Platform Orchestrator. That's a very simple command. Now create an application. It is aptly called the Quickstart, and it has already been created and is visible in the application section. And here's our Quickstart. It is created with a default development environment that is empty yet. We're going to deploy into the development environment in a minute. And we're going to actually create more environments going forward, but stay tuned. So the application is just an empty shell at this moment, waiting for workloads to be deployed into them. It has a default development environment that we saw. We can also query that using the CLI. So get environments, we see the development environment and nothing else yet. Now to actually deploy a workload, we are heavily leaning on a workload specification that's called SCORE. SCORE is an open source workload specification that Humanitec is a contributor to, and we have adopted that specification as the concept we're going to use going forward in defining our workloads that we can then deploy. There is a convenience function in the humctl CLI, which lets us create a dummy SCORE file. We go humctl SCORE init. And if I go to my VS Code, this is it. So this is a dummy SCORE file. It has more than we need. So let's simplify it a little bit. So we'll change the name of a workload to Quickstart. Let's do that. Great. So we'll remove, we'll change the target port to 8080. So this is a service definition. Stay tuned. We're going to go over the details in a minute. So this is the service definition. Is the service that would expose our workload to network traffic. This looks very familiar if you're working with Kubernetes object, and that is not a coincidence because Core is designed for containerized workloads, and it adopts a lot of the conventions that have developed around that ecosystem. So we have a service definition, port, a target port, and we're going to change the image to a demo image for our deployment, which is going to be this one. And to keep it simple, we're going to remove the entire resources section, which has more than we need at this point. We're going to add more resources later, but for now, we just have a workload with no resources attached to it. And we're going to remove all of the variables and add a new one, which we call over at MRTD. The message of the day will be hello Quickstart. Great, save it. Let's have a look at it in total, see if it looks good. So this is our SCORE file. Going forward, we have a name, we have a service definition, we have one container and an image and a variable set. Looks good. Great. So if you want to spare yourself the trouble and be sure that you did the right edits, there is a reference solution for this core file that you can just copy at this point by executing this command right here. But we're confident that we did the right thing, so we're going to actually deploy this core file and say, hey, humctl SCORE deploy and see what happens. The target for the deployment is set through environment variables that were set as part of the setup script. So the CLI will know the target application is the Quickstart and the target environment is development. So let's do that. humctl SCORE deploy. It's a lot of output. Deployment's going on. Still in progress. And we get a status succeeded, which is nice. Great. So we're going to go to the portal and inspect the result. So here's our development environment, and we now expect something to have happened. So let's see. We have the overview page of our environment. So that's the development environment. We have a deployment status of running, which is cool. It's deployed just a few seconds ago by myself. And we have one workload, which is called the Quickstart. And we have a number of shared resources that were automatically deployed along with it. So there's always a base environment, a cluster, a namespace, and some logging configuration. This is out of scope for this Quickstart. More advanced topics, but just to let you know, some stuff is always provisioned for you. Great. If I go to my workload, I'll see one running pod, which is called, with one container, which is called Hello World. Great. So let's now have a look at what happened. I mentioned that there was a namespace that was provisioned. So let's take a look at our cluster. Excuse me. Over here. So let's take a look at our cluster and see what the namespace was. So out of these active resources that we just saw down here, we can see that there's a namespace name. By default, the Platform Orchestrator creates these very unique namespace names, which is just a GUID. You can change that if you want. That's a different topic. You'll find instructions in the developer docs as well. But as a default, it's going to apply those GUIDs as the namespace name. So we now expect this namespace to be found on our cluster. Let's have a look and see what we can extract from it. So we're going to read this information that I just showed you into an environment variable. Here it is. I'm going to see, okay, kubectl get all, what do we have in the namespace? So we have a pod and a service and a deployment and a replica set. So there's just a very, very standard Kubernetes deployment that just took place. And here's a Quickstart pod and status running right here. Great. So there is no ingress configured for the sake of simplicity for this Quickstart. It would require some more stuff to do. We would need an ingress controller and some routing and whatnot. So to keep it simple, we did not deploy some ingress solution. So instead, to actually access the application and the web interface that it has, I'm just going to do a simple kubectl port forward at this point and use that to access our environment. So we now have a port forward from the local 8080 to my services 8080, and we should now see the UI of the demo app with the message of the day, hello Quickstart. Fantastic. Click the port forwarding again, and that concludes our first deployment. So let's recap real quick. Our setup grew quite a bit. So we now have a score file that defines a single workload, which is a Hello World workload consisting of one container. And using the cloud account and the resource definition we created earlier, we could deploy into the development environment of our sample application, which made the Platform Orchestrator perform an actual deployment to our cluster, create a namespace, deploy the workloads into it, and that's what we just saw. So let's go ahead and apply some further customizations. So I mentioned there is a way to make those namespace names a little more beautiful. So let's do that. The namespace is also a resource definition type. So the way to access to actually change the namespace is to create a resource definition for namespaces that defines how we want to create those names. There is a sample resource definition that we can use for that purpose. I'm just going to download from GitHub at this point. So let's do that. Download our sample file. There it is. and we should now be able to see it in our VS Code. So here's our custom namespace YAML. And we're going to modify it a little bit, so we don't need all of the aspects that are in here. So we're going to modify it and say, okay, we change the ID and the name to Quickstart namespace. So custom namespace is a Quickstart namespace, just to make it unique. And remove the label section down here. We're going to need that. And this is it. Save it. And the key item of this resource definition is actually this part right here. This name defines how the name of the namespace is going to be set up. It uses some placeholders, which is another concept out of the Platform Orchestrator. So with any deployment, you have access to the context of that deployment that you can then use to shape the resources. In this case, to compute another name for your target namespace. So the name is going to be composed out of the environment ID and the application ID that the deployment is taking place into. There's a whole section on the placeholders and the developer documentation if you want to check it out. At this point, that's all you need to know. Great. The next thing to adjust is the matching criteria. The matching criteria down here, they define for any resource definition, well, in what situation should this resource definition be chosen over all others. There can be more than one resource definition for namespaces. There already is a default one. This is the one that constructs the GUID type namespaces. This one will overlay it. If you want, you can specialize the use of resource definitions by adding more matching criteria. At this point, we don't have to do that. It's already enough to have the empty criteria in here. This will already override the default one. So again, there is a sample solution that you can use. So if you want to say, well, I don't want to edit it myself, I want to be sure I did the right thing, you can use the sample solution. Let's do this at this point. So we've done that too. So we'll overwrite this file with a custom namespace. I actually wouldn't have had to do that, just to show you that this is possible. So this created the same result that we just created before manually. Great. So we're now going to apply the resource definition to the Platform Orchestrator by again doing humcutl apply, choosing our custom namespace. And this was it. And if I go to the resource management section of the portal again, filtered by Quickstart, I would now expect to find both the previously existing resource definition for our cluster, which is right here, and the new resource definition for our Quickstart namespace that we just created. Great. So nothing has changed yet on our cluster, but we have a new resource definition for namespaces ready. So to actually put that to use, we're going to have to redeploy again. So we're going to execute the same command as before, just going to do humcutl core deploy. And through that deployment, the Platform Orchestrator will again match the most appropriate resource definitions to that deployment. And in this case, it will match the new namespace resource definition that we just made available, which will lead to another namespace being created. So if we repeat the command from earlier, again, read the namespace name from the active resources. It is now development Quickstart, which adheres to the pattern that was defined in the resource definition. Remember, it was the context environment ID with a dash and the context application ID, which makes it development-Quickstart. Great. So we now have a beautified namespace. And again, if we look into that namespace on the cluster, we're going to see the same objects as before. So here's our part, our service, our deployment, our replica set deployed 46 seconds ago. So there was a new deployment into that new namespace that the Platform Orchestrator created. And that concludes this chapter. So we have now changed something more. We have included a new resource definition for namespaces. It was matched to the new deployment that we performed, and that made the Platform Orchestrator create a pretty namespace with a workload in it as before. So let's continue and expand our application by a new environment. Now remember, if you go into the portal real quick to your application, there is just one environment right now, which is by default called development. Now, usually you will have a cadence of environments for your engineering organization, for your team. It can be any pattern you like. So you have a development and a testing or staging and a production environment. That is your choice. But you will want to deploy your workloads through that cadence. So what the orchestrator offers is the way to define more environments for you to use, and that's what I'm going to do at this point. I'm going to create a staging environment. So let's do that and go Humcuttle create environment of type staging. Excuse me, that didn't work. There we go. So first we're going to create an environment type, which I already have, so that it creates an error. So I already have an environment type staging, so that is fine. You can subdivide, you can organize your environment by environment types. You can then use those types in matching criteria, but that's an advanced topic that we're going to skip for now, just so you know each environment has an environment type. So I already have an environment type for staging, that's fine. And I'm now going to create the actual environment, which is called staging. And there we go. If I go back to the portal, I should now see on refresh. If I don't want to wait, here's our new environment called staging. And it's yet empty. Nothing has been deployed into it yet, which is correct. We're going to do that in just a minute. So we're going to apply the same command again. So here's our Humcuttle deploy, but this time with an environment staging. One thing I didn't mention earlier, what Humcuttle does, when it does this core deploy, it uses a file called core.yaml by default if you don't specify anything else. So that is the core file that we provided earlier that provides the basis for this deployment. And we're using the same core file again, and that's actually a very, very important concept. This core file is meant to be completely environment agnostic. There is no information contained in here that is specific to the development or staging or production environment. The point is that you can use that core file, make it part of your code, and deploy through all of your environments without a change to that file. So let's do Humcuttle core deploy into the staging environment. We get the familiar output. Takes a while, it provisions a lot of stuff, and our deployment has succeeded. Great. Now, for every environment, the Platform Orchestrator will provision a new namespace on the cluster. Each environment is physically separate, and assuming that it's deploying to the same cluster, which is the case for this setup, it will create a new namespace. So let's extract the information about the namespace after looking at the environment real quick. So we now have a running deployment in our staging environment. It looks just the same. It has the one Quickstart workload, and there is a shared resource of type namespace down here, and it has a different name. Again, adhering to the pattern we defined in the resource definition, it's called staging-quickstart. So if I execute this command to extract that information from the Platform Orchestrator, I will get staging quickstart. And if we look at the objects on the cluster, I will see the same type of objects again. They are not the same objects, just the same type. It's another deployment in a separate namespace consisting of the same workload and the same service, So there's one pod, one service, one deployment, one replica set. Same stuff as in development, where we can what we just advanced into the next environment in our cadence. Great, and that already concludes this chapter. So we added something new again. We added a new environment called staging to our application. We performed another humcuddles core deploy using the same score file, and that made the platform orchestrator again pick the same cluster, but create a new namespace using the naming pattern that we also defined, and deploy our workload and the service onto it. Great. So our next step is to add our first resource to our setup. Because so far all we deployed is a simple pod. It had a web interface, we could access it via a service, but there was no resource around it that this pod actually used. So resource management is a huge topic, and we're just going to briefly touch it here, and we'll create a very, very simple resource, which will be an in-cluster Postgres database. So we're going to deploy a pod that's running a Postgres database, and our workload will connect to it. So for convenience, we are providing what's called a collection of resource packs. Resource packs are pre-packaged definitions of resources that are commonly used in cloud-based setups. There are a number of resource packs. There are packs for all of the 3 major clouds, and there is also a resource packs for in-cluster deployments. And this is what we're going to use here. So we're going to use the in-cluster resource pack to deploy a Postgres database onto our cluster with just a few lines of code. It's Terraform based, so that's what we needed Terraform for. And to use it, we're just going to clone this resource packs in cluster repo that's also public on GitHub into our environment for starters. So let's clone this repo. And we're now going to move to the Postgres example directory and prepare the Terraform variables file. Right, so we now have Terraform TFRs, and let's look at the setup right here. So we now have the resource packs in cluster right here. And now we have to modify the main file to kind of customize our setup a little bit. So the resource pack assumes that it brings its own application. We don't want that, so we're going to remove the example application at this point, and we'll also set the app ID to the fixed value of Quickstart. Save it. Great. And this is it. So we're now going to apply this resource pack to our environment by going Terraform init. It's going to download all the providers. So it's using a local state only, so it's very, very simple. And we're doing a Terraform apply auto proof. And what that does is it does not yet deploy a database. What it does is it creates a resource definition for a Postgres database. I'm going to look at it in a minute. Let's first back out of that directory again. So what we now have is a new resource definition in our Platform Orchestrator. You can look at the list of all the definitions, grab it. So here's the new resource definition. It is also visible in the portal. If I go to my resource management section, go Postgres, I have my Humanitec resource Postgres right here, which was just, this is the in-cluster Postgres that was just created by the resource pack. Great, so we'll now have to expand our score file to request a Postgres database. the concept of score says that workloads can request resources, and it's the concern of the Platform Orchestrator to then actually take care of provisioning it. So I'm going to go back to our score file, and we're going to add a resources section. So let's get add a resources section, and we request a resource that we name DB. So this name you can choose on your own, and it has a type of Postgres. The Platform Orchestrator supports a vast array of resource types, and it has to be one of the supported types that you put in here. For Postgres database, well, that's Postgres. The other thing that we're going to do is we will create a new environment variable for our container that will then make it connect to that Postgres database. So let's copy that and add it as a second environment variable. There you go. So this environment variable effectively creates a Postgres connection string. The pattern might look familiar to you. And the funny thing is that this string contains placeholders. Those placeholders reference the resource that we have defined down here. So here's our resources of name DB and of type Postgres. And what we can do up here is say, hey, for the username, please use whatever this DB resource outputs as its username at runtime. Similarly, for the password and the host and the port and the DB name. So the developer does not have to know those parameters. They actually don't exist yet, but we can already wire them up. We say we know that this resource will expose those properties because that's defined in the resource type. So we can wire them up, prepare our connection string, and the Platform Orchestrator will inject the values at runtime and populate this variable so that a workload can effectively connect to our database. So let's save that and follow our instructions. Again, there's a sample score file that we can use, but we are confident that we did the right thing. So we're going to just do another humcutl score deploy. Back to our console, to humcutl score deploy. Since I did not name an environment, the default again is the development environment. So we're performing another deployment with the updated score file to our development environment. So now something should have changed. We added this resource to our score file. So we would now expect to see new elements to have appeared in our deployment. So again, here's our score deploy, here's our workload. If we go to our workload, we now have a resource dependency that we didn't have before. So here's our Postgres resource dependency. It was created using the resource definition out of the resource pack, and it has these properties. We do not get the secret properties exposed, such like the username and the password, obviously, but those are the data of our Postgres database. So if we now look onto our cluster real quick and see what objects we have in the development namespace, there's a new pod and a new service and a new replica set and a stateful set that was now created. So here's a stateful set for the Postgres database, which led to the creation of a running pod for Postgres and a service exposing that Postgres on the standard port 5432. Great. So again, let's create this little helper port forward. And access our UI. There you go. Now we see that the database could be connected because we have a count result of 0. The database is empty yet. We had no output in here previously, but now we could connect to that database. And should we would our application have a database client installed or some use for it, it could now populate this database with data and do whatever it wants. So it was wired up using that connection string to the workload by the Platform Orchestrator. And that again concludes this chapter. So even more stuff has now happened. We now have added a new database, a new resource to the score file with a resource type of Postgres, performed another deployment to the development environment, and the Platform Orchestrator picked up that resource request and actually provisioned an in-cluster Postgres in the same namespace using the resource definition that we prepared by the resource pack. Fantastic. Now, for our next exercise, we're going to apply some environment-specific configuration. Remember that we have the concept of environments in the Platform Orchestrator. We set up 2 environments so far, development, staging. There could be any number. And it's very common that you want to apply some environment-specific configuration to your workloads. And one way to do that is to treat the environment as another type of resource. So what we're now going to do is we're going to add another resource to our score file. Let's go back to our score file and let's add this env part. We don't need that, to our resources section. So besides the existing database resource, we now have this type environment resource right here. That's another reserved resource type, which lets us tap into resource-specific configuration and the Platform Orchestrator. So we will now refer to this resource by adding another environment variable. So instead of the hard-coded value hello Quickstart, we will now say, okay, please reference this env resource. So this is the one right here. Resource is called env. So reference this env resource and extract a value which is called MOTD. Now we didn't define this value yet. That's our next step. So where does it come from? That brings us to the concept of shared values. Shared values are values I can set on an application or environment level in the Platform Orchestrator. Let me do that and then have a look to explain it in more detail. So I'm going to create a new shared resource, a new shared value, call it MOTD, with a fixed string of default MOTD in the application level. So the empty environment parameter tells the Platform Orchestrator, okay, this shall be defined on the application level. You can override those variables on an environment level. That's what we're going to do next. So we're going to create the same value MOTD on an environment staging level right here. So to make this a little more graspable, let's look at our application. So here's our application, and in values and secrets, I now see an an application level variable, the key MOTD, and this is the default MOTD set as the shared value as a value. And if I go to my staging environment, I would see an override of that value set secrets. So here's a little bigger. So here's another MOTD, but it has a different value. This is the staging value for this MOTD variable, and it has not been deployed yet. I'm going to change that now. Let's go back to our instructions. I'm now going to deploy into both our development and staging environments. So let's deploy to development first. This time we're not getting the output because I didn't set the --wait parameter. So it just triggers the deployment and then returns. But we just assume everything went all right. So if we now again hook onto our application and do the port forwarding on our development namespace and refresh our view, and if everything went well, we're now getting the updated message of the day, which is the default message of the day from the application level shared value. Again, the score file says use the environment value MOTD as the value for this environment variable, which is then displayed on the UI. So for the development environment, it took this shared value from the application level. There was no override for the environment on dev. So it took the shared value from the application level. However, when we quit this port forwarding and do the same for the namespace staging, refresh our view, we will get the message of the day for the overridden staging value. So that is the one that we see right here. So it's the staging environment which has an override for this value. And by the way, since we deployed to staging with the current score file, which contains the Postgres database, we now also got the Postgres deployment onto the staging environment, which we didn't have previously. So if we look at the staging namespace, it now caught up to the latest definition of our workload. So we now have the Quickstart, and we also have the Postgres database right here. Great. So to recap, what do we have? We now have even more stuff. We now have a resource of type environment in our score file. We changed the variable definition for the message of the day to tap into that resource and say, hey, please extract this value. And we provided both a shared value on the application level with one string and an overridden shared value on the staging level with another string. And those variables were extracted for the workload, and we got a different output for our development and staging environments, respectively. That's one way to provide environment-specific values for your applications and use them in your workloads. And with that, let's take it one step further and look at a scenario where we have more than one workload running. So let's now deploy another workload. To do that, we need another score file. Because the convention is that there is one score file per workload. Workload can have more than one container defined in the score file, but separate workloads require different score files because they can have different dependencies as well. So we're going to copy the score file into an identical file, which we call crazy score. I'm going to edit it and set the name of crazy score, which is right here. I'm going to add the name. Let me just get my reference real quick. So we're gonna edit it and change the name to Crazy Quickstart. So the name will be Crazy Quickstart, and everything else will remain just the same. So it's going to be an identical workload with the same values, the same resources, just the same stuff under a different name. So let's deploy that. Humcuttle score deploy. But this time we're going to specify the crazy score YAML as our source. Again, we didn't specify the wait parameter, so it immediately returns. This deployment targeted the development environment again because we didn't specify anything else. That was our default set through the environment. So we would now expect something to have changed in our development environment. So let's have a look right on the cluster. Get our objects in the namespace. And we can see that it has been populated by more things. So we now have the Quickstart part that we already had earlier. So here's the old part. There's a Postgres for the Quickstart. And we now also have the crazy Quickstart part itself and its associated Postgres. Because remember, we're using an identical score file. The score file also had the resource definition, the resource reference to a Postgres database. So again, the Platform Orchestrator provisioned that database for our new crazy Quickstart workload. And again, we can access it. So let's look at the crazy Quickstart, and the result will be very familiar. There we go. So just as before, it's the same, or it's an identical workload as the Quickstart, and it displays the default value in the environment, in the development environment. Great. So what if we want to share our database? Well, there's two ways of going about this. One way would be to access another workload's resources. This is not what we're going to be doing right here. Just so you know, if you wanted to access your a resource from another workload in the same application, that is possible using a special notation. We have a hint placed in the instructions right here. Feel free to try this on your own. We're not going to do this at this point. We're going to use a different method. So just, you know, your crazy Quickstart workload could access the Postgres of the other workload and vice versa. However, that's not really what we want to do. We want to define a proper shared resource. So if we have a common database that's supposed to be used by both workloads, we're going to define a proper shared resource. And there's a different way to go about this. And this way is to define an ID for your resource in your score file. And that's what we're going to do now. So we're going to have to add this ID for a resource in both score files and set it to the same value so that it will then become the same resource. So let's do that. I'm going to start with a crazy score file. I'm going to say type Postgres, and let me just real quick see what the value is supposed to be. So we're going to add this ID and set it to common-pg. So common Postgres, save it. And we're going to do the same thing for our score file for the first workload. So again, Postgres common pg, Postgres common pg. Again, there are simple solutions for that if you want to skip the editing. And now, you probably guessed it, what we have to do is to do another redeploy to apply the changes from our score file to the real world. So let's deploy both score files into the development environment 1, 2. Great. So let's go and check the result. So if we go to our Quickstart application and select the development environment, the deployment is still going on, so this should turn healthy any minute. While we're waiting for that, there you go. We now get a new shared resource down here. Remember, it was only the 4 resources above up to this point. Now we have a new shared resource which is called common-pg, and it's of type Postgres. So while the deployment is going on, let's check the result on the cluster. So in our namespace development, it now looks like that. we have a new shared common Postgres running right here. We also still have the old Postgres pods running. That's because the Platform Orchestrator by design is quite conservative when it comes to tearing down resources. Because in case of a rollback, you might want to access that database that you had earlier and it was connected to a workload using that old score file and not lose your data, right? So it will hang on to these databases unless you actually delete the environment or delete the application. Great. So to prove that both workloads are actually using the same database, let's output the connection string that they use. So we're going to read the environment variable from the workloads of both workloads. So this is number 1 and that is number 2. And we can see that the connection string right here and right here is identical. So both workloads are accessing the same database, which we made shared again by using the same resource ID in our score files. So to reiterate, we added this line right here and we added this line right here, and that led to the Platform Orchestrator creating a shared resource for those two workloads. So this is what we have right now. So we have new resource ID right here and right here, and our crazy workload and our older workload are now accessing the same Postgres database. And that was it. Just one thing to mention, our staging namespace does not have the shared setup yet because we didn't deploy to that environment yet. Didn't deploy to staging, we just deployed to development. So with the next deployment of our two workloads into the staging namespace, the staging environment, we'll get the same setup in the staging namespace as well. And that concludes the content part of the Quickstart. The only thing left to do, unless you want to keep experimenting with what you have, is cleaning up. So let's do that. Let's clean up after ourselves and delete everything. So first of all, we're going to delete the application and the Platform Orchestrator. That is one simple and very, very powerful command. Use it wisely because this will actually tear down everything. It will delete both namespaces from the cluster and all resources that are inside them. So if we now go to our namespace overview, we can see both namespaces in status terminating, and that will be gone very soon. If we go to the Platform Orchestrator, we will also see that the application is gone from the list. So, unless you want to continue using it, we're also going to delete the custom namespace definition for our prettified namespace naming. Let's do that. We're also going to remove the in-cluster Postgres resource definition that we installed using the resource pack. This is handled through a Terraform destroy, executed in the resource pack directory. So let's do that. Everything has been destroyed. So next thing is to delete the cluster resource definition unless you want to continue using it. So if we still have our cluster connected to the Platform Orchestrator, you could perform more deployments onto it right now. If you want to continue using it, stop here. If you want to tear down properly and forget, we're now going to delete the resource definition for the cluster. We're going to delete the cloud account and all the credentials that were set up in the cloud infrastructure that are backing it. So all the principals, permissions, whatever your cloud requires will now be cleaned up through this script as well. There you go. Great. And if you set up a cluster using a convenience script, again, here's the corresponding cleanup script that will delete your cluster. I didn't do that, so I'm not going to execute it at this point. And finally, I'm going to remove my Quickstart repository on my local machine. And that was it. So finally, I'm going to invite you to recap what we learned in this Quickstart. So we did a number of things. We created an environment agnostic workload specification using SCORE, starting out very simple, just with a workload and a container and a service. We connected the Platform Orchestrator to our cloud environment using a cloud account and then using a resource definition that was using the cloud account. We created an application and its environment, starting out with development and advancing into staging. We performed deployments into each of these environments, always updating the setup with every new deployment according to what the SCORE file specifies. We supplied environment-specific values, which can be set both on the application and environment level. We provisioned an in-cluster database resource using a resource pack, and we provided both private and shared resources. So the first resource instantiation of the Postgres was private to each workload, and then we upgraded it to a shared resource by setting this ID. Remember that the SCORE file did not change when deploying across environments. So you define your SCORE file, you deploy it to development, things happen, you deploy it to staging, and the same setup will be created for you according to the resource definitions that are set up in your Platform Orchestrator. And this was it. That was the Humanitec Quickstart. So there's a number of things you could do, and we provided some suggestions on the next steps page. So if you want, you might not want to explore our reference architectures. We have reference architectures for all of the major clouds that install an opinionated good practice setup for you. So it will install a cluster with all the surrounding infrastructure, will connect the cluster to the orchestrator, and you will be ready to go to experiment on your own. That's a very powerful, very useful thing to get started and get more experience with the Humanitec products. There's also an extended learning path, which you can find in the same training section right next to the Quickstart, which is called Master Your Internal Developer Platform. It's a lot longer, it takes a lot more time, and goes a lot deeper into the theory that's behind platform engineering. You might also want to have a look at the other resource packs for the major clouds. I just mentioned them. They're very, very useful, and you can provision cloud-based resources using the Platform Orchestrator with just a few lines of code. Obviously, I have more material in terms of tutorials in our developer documents, which are in our documentation in the tutorial section right here. And if you have questions, you might also always book a session with one of our platform architects and dive deeper. And with that, I'll just say happy platforming. Thanks for sticking around. Have fun with our products. I was Toby. Have a good day.